Welcome to my channel, where we make everything science, technology, engineering, and mathematics comprehensive, easy to assimilate, fun, and enjoying. Today we are going to treat some questions in a straight line equation. Let's begin. My name is Oladimeji, and I'm here to make sure that you get it, enjoy it, and find it easy to handle anytime. If you have learned it before, this is the time for you to revise. And if you are just learning it for improvement in homework, assignment, and research, this will assist you. Kindly subscribe, make comments, and share to encourage. Thank you very much. I am Oladimeji, as I told you initially, as a facilitator in this section. Let's begin. The question reads, point A is 11,1 and point B is 2,6. Point P lies on the line AB and 2AP equals to PB. Find the coordinates of P. From what we have treated, we have said that when we have point A, x1, y1, and point B, x2, y2, and the line is divided in the ratio n to n. We are going to have it like this. The points of that division is going to be n into x2 plus n into x1 over m plus n. We also have it for that for y, as that for y, n into y2 plus n into y1 over m plus n. Therefore, for this question, our A is 11,1 and our B is 2,6. Therefore, point P, we are going to have the coordinates of P as, because it divides the line in the ratio 2 to 1. So we have like this: 2 into 2 plus 1 into 11 over 2 plus 1. That is for the x. And for the y, we have 2 into 6 plus 1 over 2 plus 1. So it's going to be 4 plus 11 over 3 and 12 plus 1 over 3. So we have it as this. Point P is going to be 5, that is 15 over 3, and then 13 over 3. The question reads, find the gradient between the following pairs of parts. 1. AP A over P and AQ A over Q. 2. 81 square 281 and 82 square and 282. Let's do one. Anytime you want to tackle gradient question, gradient is always change in y over change in x. So in this instance, our change in y for the first one is going to be A over Q minus A over P over AQ minus AP. So what do we have here? We have A into 1 over Q minus 1 over P over A into Q minus P. So what do we have now? This one cancels this. We are going to have P minus Q all over PQ divided by Q minus P. So that gives P minus Q over PQ times 1 over Q minus P. So when you cancel this one, it becomes minus 1. So our answer for the first question is going to be minus 1 over PQ. For the second question, our change in y, we are going to have 2ac2 minus 2ac1 over ac2 squared minus ac1 squared. So we can factorize the numerator and denominator. So we have 2a into t2 minus t1 over a into t2 squared minus t1 squared. So this one we cancel this. Let's continue factorizing. We are going to have 2 into t2 minus t1 over t2 minus t1 into t2 plus t1. So this one we cancel this. So our final answer is going to be 2 over t2 minus t1. That's the gradients for the second point. We have gotten that for the first point. The question says, show that the 4 points 118, 5, 8, minus 1, minus 2, minus 5, 8 are vertices of a parallelogram. What do we know about parallelogram? We know that the opposite sides are parallel, and which means that the opposite sides, the gradient of the opposite sides, will be equal. So let's say we have point A to be 180, B 5, 8, C minus 1, minus 2, D minus 5, 8. We can even make rough sketch to have idea of how it will look like. Let's say we have it like this. We have 118. Okay, 1. Okay, let's make it bigger. Just for us to have idea of how it will look like. Though it's not necessary. So we have 118. Okay, 118. B 5, 8. 5, 8. C minus 1, minus 2. C minus 1, minus 2. And D minus 5, 8. We have D minus 5, 8. So this is what it will look like. So from our drawings now, it means that AB should be parallel to DC and AD should be parallel to CD. We also know that the opposite sides of parallelogram are equal. So let's quickly check. What are the gradients of AD? So that will be 8 minus 18 over minus 5 minus 1. So that's minus 10 over minus 6. 8 minus 18 minus 5 minus 1. So that is for AD. Let's check gradients of BC. BC. So that will be 8 minus 2 over 5 minus 1. So that will give us 10 over 6. So you can see that the gradients are equal for the opposite side here. Let's check gradient of BC. Yeah. Let's check AB and DC. Gradient of AB. We have that one to be 8 minus 18 over 5 minus 1 minus 10 over 4. So that is minus 10 over 4. Let's check gradient of DC. DC. So we have 8 minus 2 over minus 5 minus 1. So we have this one as 10 over minus 4. So you can see that the gradients of the opposite sides are equal. The gradients. So we have this. Now, the other thing we know about opposite sides of parallelogram is that the sides, opposite sides are also equal. So we can also check what is the length of DA? What is the length of CD? We know how to calculate that now. DA squared is equal to 8, okay, minus 5 minus 1 squared plus 8 minus 18 squared. So that is 36 plus 100. 136. So let's check the length of CB. 8 minus 1 squared plus 8 minus 2 squared CB plus 5 minus 1 all squared. This is going to give me 100 plus 6, 36. So you can see that the opposite sides are equal. If you should check for AD and DC, AB and DC. So AB squared will be equal to 8 minus 18 all squared plus 5 minus 1 all squared. So that will be 100 plus 16, 116. Let's check for DC squared. We have DC squared, that's 8 minus 2 all squared plus minus 5 minus 1 all squared. 8 minus 2 is 10, so this one is 100. Minus 5 minus 1, that is minus 4. Minus 4 squared is 16. So we can see the opposite sides are parallel and are equal. So that shows that these are vertices of parallelogram. Now we have a question. The vertices of a triangle are A minus 5 minus 5, B 70, C 310. Calculate the length of AB and AC. The area of the triangle. See the value of sine BAC. Because of some questions asked like area and value of sine BAC, it might be helpful to have diagram estimate of the triangle. Let's try. We have it like this. We have point A minus 5 minus 5, B 70, C 310. So let's see. A minus 5 minus 5. B 710. 70. 70. C 310. 310. 310. With this, we can have some to make us to see some things than to be imagining. Here we have the first question. It says length of AB and AC. AB is equal to, from our knowledge, AB squared. Let's start from there. AB squared will be 7 minus 5 squared plus 0 minus 5 all squared. That gives 12 squared plus 5 squared, which is equal to 144 plus 25, that's 169. So AB is root of 169, is 13. Now, we also have to get AC. AC squared is 3 minus 5 all squared plus 10 minus 5 all squared. That is A squared plus 4 plus 2, 2, 5. That is 2, 8, 9. So AC is square root of 2, 8, 9. 17. It now asks us for the area of the triangle and do it in any form. You can find the equation of this straight line, the distance from here, and you can get your answer. Let's see if I can try the techniques I can. You can get the area by saying, okay, let me draw and this. Let me use this here now. So the area of this triangle will be equal to the triangle. Let me make this place DE. So area of triangle ABC will be equal to area of triangle ACD plus trapezium, area of trapezium, DCBE minus triangle ABE. You know why? I have formula for this shape easily. ACD. I can easily get that one. I can easily get that of this trapezium, and I can easily get that of this triangle. But for these ones, I don't know this angle. I will start needing to get this angle. That is why I find that to be difficult. So now let's go about it, and you see it will be straightforward. What is the area of ACD? That is will be equal to half. What's my base? DA. And what is DA? That is 3 minus 5. What is my height? 10 minus 5 from this place to this place. 10 minus 5. So which is half into 8 times 15. That's 4 times 15, that's 16. Now let's see. Area of trapezium DCBE. Trapezium DCBE is half the sum of the heights. And what is this? This one is 10 minus 5. 10 minus 5. Plus 0 minus 5. I hope you are getting it now. This distance here. You know, the formula for the area of trapezium is half the sum of the parallel sides multiplied by the distance. And what is the distance now? It is this. That is 7 minus 3. 7 minus 3. So this will be half into, what is this one? 15 plus 5. 15 plus 5 times 4. That is 40. 15 plus 5 times 4. That's 40. Now what's the area of our triangle? ABE is half. What is this base? It is 7 minus 5 from here to here. 7 minus 5. What is the height? 0 minus 5. And that is half times 12 times 5, which is 30. So the area of the triangle, ABC is equal to 60 plus 40 minus 30. 70 units squared. 70 units squared. Now we know that area of a triangle, let's call this place beta. Area will be half into the base times the other side sine alpha. So that will be half times AC sine beta. Please remember, it will be length of this place times length of this place sine this place. So we have 70 is equal to half. We've got to the length of AB and AC before. What's AB? We calculated AB to be 13 and AC 17 sine beta. So sine beta, that is sine BAC, will be equal to 70 times 2 over 13 times 17, which is 140 over 13 times 17. And that will be 140 over 221. The three vertices of ABC of a triangle are 2, 5, minus 2, 3, minus 1, 4. This is the midpoint of BC. Verify that AB squared plus AC squared equals 2AD squared plus BC squared over 2. Find the area of the quadrilateral with the vertices as the origin and points A, B, and C. Let's draw the diagram to represent this. The first point is 2, 5. 2, 5. That's A. The second point is minus 2, 3. Minus 2, 3. B. And the third point is minus 1, 4. And so we have a triangle like this. D is the midpoint of BC. D. So how do you find D? It is half. You know how to find midpoint of a line. You add the two x-axis or y-axis and divide by 2. So we have minus 2 minus 1. So we have D. And then 3 plus 4. So what do we have there? So these are D components. So that is minus 3 over 2 and 7 over 2. That's D. It now says, verify that AB squared equals N plus AC squared. Let's find what AB squared is. This is B, 2, 3. AB squared will be equal to 2 minus 2 squared plus 5 minus 3 all squared. That gives, this one is 16. 16 plus 4, that's 20. Let's find AC squared. AC squared will give 2 minus 1 all squared plus 5 minus 4 all squared. That is 9 plus 1. That's 10. Let's find 2AD. This place. 2. Let's find AD first. AD squared. AD squared will be equal to 2 minus 3 over 2 all squared plus 5 minus 7 over 2 all squared. So this one will give me 7 over 2 squared, and that is plus 3 over 2 squared. So it's going to give me 49 plus 9, 58 over 4. Therefore, 2 AD is equal to 2 times 58 over 4. That's 2. 29. What is BC? BC squared. That is minus 1 minus 2 all squared plus 4 minus 3 all squared. That is 1 plus 1, which is 2. So BC squared over 2 will be equal to 2 over 2, which is 1. At the end of the day, let us add all this together. AB squared plus AC squared is going to give us 20 plus 10. That is 30. 2AD squared plus BC squared over 2 will be 29 plus 1, which is 30. Therefore, AB squared plus AC squared is equal to 2AD squared plus BC squared over 2. That is proved. It now says, find the area of the quadrilateral with the vertices at the origin and points A, B, and C. Now, that one is done. Let's go to the second part. It's now saying that you should find the area formed by these vertices of this triangle with the origin. So I have it like this. This is minus 2, 3. I have this as minus 1, 4. So the area will be the sum of these two trapezium minus the sum of these two triangles. What do I mean? This is A, B, and C. So let me call this place E, F, G. Area of the quadrilateral. Area of the quadrilateral of the quadrilateral E, F, O, B, C, A will be equal to area of the trapezium, area of trapezium E, B, C, F plus trapezium F, C, A, G, A, minus area of triangle E, B, O plus O, A, G. How do we go about that? You can easily find the area of the trapezium. Just try to get out the shapes that I can easily work on. That's what I did here. Trapezium E, B, C, F. What will be the height here? I have this one to be 3 and this one. So the EBCF is equal to half 3 plus 4. What is the distance from here to here? That is 1. That is minus 1 minus 2. From here to here is 1. Plus half 4 plus 5. And what is the distance from here to here? 3. So that will give me 7 over 2 plus 9 plus 27 over 2. That is 17. Let's look at the triangles now. Okay, EBCF, sorry, this one is for EBCF plus FCAG. I am adding this trapezium or trapezium. Now let's go for the triangles. Triangles EBO plus triangle OAG will be equal to half. What's the base? From here to here is 2. What is the height? 3. Plus, what is the base here? From here to here is 3. And what is the height here? 5. So, what do I have here? No, this is 2. No, 2, sorry. This place or this place is 2. So I have this, I have this. So this is 8. So area of the quadrilateral will be equal to 17 minus 8, which is 9 units squared. So please understand this very well. I try to carve out shapes that I can find the areas easily, like trapezium, square, triangles, and co. So I brought this one out, I added it to this other one, and I deducted these areas from the area of the trapezium I got. The question reads, tell if the following points are collinear. 2, 5, minus 1, minus 1, and minus 4, 7. Second question is 7, minus 3, minus 2, 1, and minus 6, 3. Now let's test for the first one for collinearity. That is, the gradient must be equal no matter the point you select. Let us take the first point as A, 2, 5, B, minus 1, and C, minus 4, minus 7. Now, let's check gradient of AB. AB, that will be minus 1, minus 2, minus 5, sorry, minus 1, minus 5, over minus 1, minus 2. That is minus 6 over minus 3. Let's check AC. That will be minus 7, minus 5, over minus 4, minus 2. That's minus 12 over minus 6. This one is 2. This one is 2. The third one will be automatically, but let's confirm. So BC, it will be minus 7, minus 1, minus 4, minus 1. So that will be minus 6 over minus 3. So that's 2. So all the points are collinear. Let's check for the second one. We have points A as 7, minus 3, B, minus 2, 1, C, minus 6 and half, and 3. So let's check for the gradients of AB. Will be 1 minus 3 over minus 2 minus 7. 1 minus 3 minus 2 minus 7. So this one is 3. No, this one is 4 over minus 9. Let's check AC. That is 3 minus 3 over minus 6 and half minus 7, which will be 6 over 13 and half. And that will be 12 over 27. 3 here, 4. Oh, sorry, this is minus. And this one will be minus 9. So you can see that the gradient of the two are equal. Now let's check with the third one. BC. We have that one to be 3 minus 1 over minus 6 and half minus 2. So that will be 2 over minus 4 and half, which will be 4 over minus 9. So all of these two are collinear. All of them are collinear. So the first line and second line, they tested positive for collinearity. The question reads, find the length of the perpendicular from 1, 4 to line 5x plus 12y plus 13 equals 0. The second question says, find perpendicular distance between minus 3, 7, and the line joining 2, minus 4, and minus 6 and 2. The third says, find the distance between the two parallel lines, 3x minus 4y plus 12 equals 0, and 3x minus 4y plus 2 equals 0. He gave us hints, difference in the distance from the origin. So let's start with the first one. We know that if we have an equation like this, ax plus by plus c equals 0, and we have another point, x1, y1. The distance, the perpendicular distance will substitute x and y with these components and divide by the square of a the root of square of a and b. So this is what it will be like: ax1 plus by1 plus c over root of a squared plus b squared. That's the distance from a point to a line. So for this one, we have x1 is equal to 1 and y1 equals to 4. And our equation is 5x plus 12y plus 13 equals to 0. Therefore, distance from 1, 4 to the given line is 5 into 1 plus 12 into 4 plus 13 over root of 5 squared plus 12 squared. So this is 5 plus 48 plus 13 over 5 squared plus 12 squared is 169. So the square root is 13. So we don't need to waste our time about that. And this is 48 plus 5, that's 53. So we have 66 over 13. Now for ease in getting the second one, we have to find the line joining 2, minus 4, and minus 6, 2. So let's start. The gradient of the line joining the 2 points is equal to 2 minus 4 over minus 6 minus 2. That is 6 over minus 8. That is minus 3 over 4. So our line will now be y plus 4 over x minus 2 will be minus 3 over 4. So therefore the line will be 4y plus 16 is equal to 6 minus 3x. So the line equation will be 4y plus 3x plus 10 equals 0. So the point is minus 3, 7. So the distance from minus 3, 7 will be gotten like as this: 4 into 7 plus 3 into minus 3 plus 10 over root of 4 squared plus 3 squared. And that is 28 plus 10, that's 38 minus 9. 29 over 5. That's the distance from this point to the line. Now for the third one, it says find the distance between these two parallel lines. Let's find for this line, for line 3x plus 4y minus 4y plus 12 equals 0. Distance from origin. Distance from origin will be equal to 12 over root of 3 squared plus 4 squared. So, because this is positive here, let's let it positive for now. So that will be 12 over 5. For the second line, the distance from the origin so distance from origin will be equal to 2 over 5. So the distance between the two lines will be the two lines will be equal to 12 over 5 minus 2 over 5, which is 10. That's 2 units. That's 2 units. The question says, find the equation of a straight line parallel to y equals to 5x over 12 plus 2 and distance 2 units from it on the opposite side to the origin. Expect the answer in gradient form. What do we mean? We have an equation like this: y equals to 5x over 12 plus 2. So, what we are saying is, it's on the opposite side of the origin of distance 2. So let's break it down. We have the equation 12y minus 5x minus 2 equals to 0. So for distance, as we have done initially, we are going to have 12y for the new line minus 5x. Oh, this one is minus 24, sorry. Minus 24. This one is minus 24. 12y minus 5x minus 24. Minus 24. That is to express for the distance. It's going to be root of 12 squared plus 5 squared. It will be equal to minus 2. Please note, the minus is there because it is on the other side of the origin. Now, we are going to have 12y minus 5x minus 24 equals to minus 26. So our equation now becomes 12y equals 5x minus 2. 5x minus 2. So as we asked to make it gradient form, the equation will now be y equals to 5 over 12x minus 2 over 12. 5x over 12 minus 1 over 6. That's the answer. The question reads, prove the distance from the point 1, 1 to the point 2t squared over 1 plus t squared and 1 minus t all squared over 1 plus t squared is the same for all values of t. So we have point 1, 1 and 2t squared over 1 plus t squared, 1 minus t all squared over 1 plus t squared. So let's find the distance. The square of the distance between them is 2t squared over 1 plus t squared minus 1 all squared plus 1 plus t squared over 1 minus t all squared over 1 plus t squared minus 1 all squared. That was this g squared. So this will now translate to 2t squared minus 1 minus t squared over 1 plus t squared all squared plus this one will be 1 plus t squared minus 2t minus 1 minus t squared over 1 plus t squared all squared. So now I can say, since the denominator is the same, I can say 1 over 1 plus t squared into, this one is going to give me t squared minus 1, and this one is going to give me, this one will cancel this, minus 2t all squared. So at the end of the day, I'm going to have c raised to the power 4 plus 1 minus 2t squared, and this one plus 4t squared. So it's going to give me into c raised to the power 4 plus 1 plus 2t squared. Then this one will be 1 over 1 plus t squared all squared. And if I factorize this one, it's going to give me t squared plus 1 all squared. So on cancelling, I have this one to be equal to 1, which is d squared. On cancelling, I have it like this, which is d squared. So d is equal to root of 1, which is 1. So the distance is constant, and the distance is 1 unit from points 1, 1 for the equation 2t squared over 1 plus t squared, and then 1 minus t squared over 1 plus t squared. The question is point A minus 4, 6 and B 4 minus 2. Find the points which divide AB externally in the ratio 1 to 3, A and B ratio 3 to 1. We've discussed about external division of lines. So if we have points x1, y1 and x2 y2, and we are to divide externally in the ratio n to n. We said that it will be mx2 minus nx1 over m minus n. Ditto for y axis. So in this instance, we have 1 to 3. Our points are A minus 4, 6, B 4 minus 2. And the ratios are 1 to 3, B 3 to 1. So for A, our division, our point is going to have these components. 3 into 4 minus 1 into minus 4 over 3 minus 1. That is for the x. And that will be 12 plus 4 over 2. That is for the x. For the y, we are going to have 3 into minus 2 minus 1 into 6 over 3 minus 1. So that is minus 6 over 2. That will be minus 6. So for the first part in the ratio 1 to 3, our coordinate is going to be 8 minus 6. Let's go to the B side. It's ratio 3 to 1. So we are going to use the 1 to multiply the B parts. So it is going to be 1 into 4 minus 3 into minus 4 over 1 minus 3. That is going to be 4 plus 4, 16 over minus 2. That's going to be minus 8. Now for the y components, we have 1 into minus 2 minus 3 into 6 over 1 minus 3. So minus 2 minus 18 minus 20 over 2 minus 2. So that's going to be 10. So for the second one, our component is going to be 10 minus 8. So our components, our coordinates rather, is going to be 10 and minus 8. The question reads, find the area of the triangle whose vertices are A, 0, 0B, and X, Y. Now let's look at what that looks like. So we have it like this. A, 0, 0B, and X, Y. We want to find this area. I want to find this. So we can easily find this by breaking into 2. We can find the perpendicular distance from here to here. And then the distance from here to here. Let's look at these two. We can use even the matrices, the determinants. So let's just look at these two. If I find if I break it into 2, I have these two points, these two diagrams, shapes, plane shapes. So this place is going to be my x, and this place will be y. So the area of the triangle will be, let's make this place O, B, A, X. Let's call this C. So the area of triangle let's call it A, B, C. Let's call this D. So triangle ABC will be equal to trapezium and triangle here. We have area of trapezium OACD plus triangle CDB minus triangle, area of triangle OAB. Let's take them one by one. What is the area of OACD? That will be half of B plus Y. Half of B plus Y into what is the distance here? X. Plus what is this one? Half Y into A minus X What is the area of this triangle? Half AB. So I'm going to have it like this. Half bx plus xy plus ay minus xy plus ab. So is equal to half. So cancel this. Bx plus ay minus ab. That will be the area of the triangle. I can also look at it like this. Let me find the length, the equation for this line. It's going to be x over a plus y over b equals to 1. So I'm going to have bx plus ay minus ab equals 0. That's the equation of this line. So the perpendicular distance from here to here is going to be the height, the orthogonal height is going to be from that point to this line is going to be bx. Oh, this one is bx plus ay. Sorry, this one is ay minus ab. Please, ay. So it's going to be bx plus ay minus ab over root of b squared plus a squared. Now, the distance from here to here, the distance ab will be equal to square root of a squared plus b, a squared plus b squared. Now, area of triangle will be equal to half the height bx plus ay minus ab over times length of ab, root of a squared plus b squared. So this one cancels it. So the area is still half to bx plus ay minus ab. So the other option is if you use the determinant formula, and you still realize that the answer still remains the same. The question reads A 4,4, B 5,3, and C 6,0. Find the equation of the perpendicular bisectors of AB and BC. Hence, calculate the coordinates of the circumcenter and the length of the circumradius of the triangle. Please, as much as possible, anytime you are treating any mathematics question, it is always good to have diagrammatic representation for ease in calculation rather than just imagining. So let's try to see what this looks like. We have, since most of it is in the positive, I'm going to have like this. Then we have 4, 4. 4. We have 4, 4. The next one is 5, 3. 5 and 3. 5, 3. And the third one is 6, 0. So we have it like this. We have this like this. And then, so 6, 0. Now, it's now asking us to find the perpendicular bisectors of AB and BC. How do we do that? To find the equation, let's find what is the gradient of AB. That is going to be 4, 3 minus 4 over 5 minus 4. So that is going to be minus 1 over 1. So gradients of perpendicular bisector of AB is plus 1. Sorry. It's going to be plus 1. That is minus 1 over minus 1. Then the midpoint of AB since that is where the line will pass through, is 4 plus 5 over 2 and 4 plus 3 over 2. So that is 9 over 2, 7 over 2. So equation of AB is given by y minus 7 over 2 over x minus 9 over 2 is equal to 1. So I have y minus 7 over 2 is equal to x minus 9 over 2. So y minus x is equal to minus 1. That is for perpendicular bisector of AB. So I call that one 1. For the next one, for BC, the gradient for BC will be 0 minus 3 over 6 minus 5. 0 minus 3 over 6 minus 5. So that is going to be minus 3. So gradient of the perpendicular bisector will be equal to minus 1 over minus 3, which is equal to 1 over 3. So the midpoint of the line BC will be equal to 6 plus 5 over 2 and 0 plus 3 over 2. So that is 11 over 2 and 3 over 2. So the equation for the perpendicular bisector equation is given by y minus 3 over 2 over x minus 11 over 2 is equal to 1 over 3. So what do I have here? I have 3y minus 9 over 2 is equal to x minus 11 over 2. So that gives me 3y minus x is equal to minus 1. So that equals equation 2. So 3y minus x equals minus 1. Now the coordinates of the circumcenter will be the intersection of the perpendicular bisectors, and that is gotten by solving equation 1 and 2. So I have y minus x equals to minus 1 and 3y minus x equals minus 1. So let's call this one equation 1, equation 2. So let me add the two. Okay, let's subtract equation 1 from 2. So I have 2y equals to 0. 2y will equal to 0. So y equals 0. And x will be equal to 1. So the point of intersection is the circumcenter is 1, 0. And to find the radius of the circumcircle, calculate the coordinates of the circumcenter and the length of the circumradius. It will be the distance from the circumcenter to any of the vertices. So let's do this one since it will be very easy. So circumradius r will be equal to square root of 6 minus 1 all squared minus 0 squared. So which is equal to 5 squared. So circumradius is equal to 5 units. The question says the sides OA, OC of a parallelogram lie along the lines 3y equals to x, y equals 3x respectively, and B is the point 4, 3. Find in their simplest forms the equations of the lines which contain the side AB, BC, and the diagonal AC. Here now, we have the points, and the origin is part of the parallelogram. The diagram is given for this question. So we have B there, we have O here, A and C. Now to find the equations of the lines which contain the sides AB and BC, they have been given these ones. We know that AB is parallel to OC, so they have the same gradients. So gradients for AB will be the same thing as gradients for OC. Gradients should be the same. So what happens now? The gradient is 3. Therefore, for line AB, we have y minus 3 over x minus 4, because it passes through those, that point will be equal to 3. So we have y minus 3 equals to 3x minus 12. Y minus 3x equals minus 9. That is for AB. So for the side BC, is parallel to 3y equals to x. So BC is parallel to OA, and gradient is equal to 1 over 3. The gradient is 1 over 3. So, okay, OA, BC, since it passes through this place, we are going to have y minus 3 over x minus 4 is equal to 1 over 3. So, we are going to have 3y minus 9 is equal to x minus 4. So, our equation will now be 3y minus x is equal to 5. That is for BC. Now it says the diagonal AC. The diagonal AC. So that requires that we have to find the points C and A. The point C and A. So to find point C is going to be the intersection of y equals 3x and line BC. 3y minus. So let's see. To find coordinates C, I'm going to have 3y minus x equals 5 and y equals 3x. So that will mean okay, that will give me 9x, sorry, minus x is equal to 5. So 8x equals 5. X equals 5 over 8. And if x equals to 5 over 8, y will be equal to 15 over 8. That is for point C. That is for point C. Now to find point A, it will be the intersection of 3y equals to x and line AB, yeah, and then y minus 3x is equal to minus 9. Y minus 3x equals to minus 9. So to solve for A, let me make x to be 3y here. So y minus 9x is going to give me minus 9. Oh, sorry. Since y is equal to minus, x equals to 3y. So y minus 9y is equal to minus 9. So minus 8y is equal to minus 9. So for the diagonal AC, The equation is going to be y minus 15 over 8 over x minus 5 over 8 is equal to 9 over 8 minus 15 over 8 over 27 over 8 minus 5 over 8, which will give me minus 6 over 8 over 22 over 8, which will give me minus 3 over 11. Now, this will now be y minus 15 over 8 over x minus 5 over 8 minus 3 over 11. And that is 8y minus 15 over 8 over 8x minus 5 over 8 minus 3 over 11. At the end of this, it's going to give me 8y minus 15 over 8x minus 5 minus 3 over 11. So which makes it simple to handle now. I'm going to have it like this. 11 into 8y minus 15. I hope you are getting it. It's going to give me minus 3 into 8x minus 5. So this is 88y minus 165 will be equal to 15 minus 24x. So the equation can still be resolved like this. 88y plus 24x is 15 plus 165, 180. So dividing 2 by 4 again, I can have it like this. 22y plus 6x is equal to 45. So that is the equation of the diagonal. So we have gotten the whole questions asked.